Okay guys, we have a diagram. We have PS is parallel to QR. So PS is parallel to QR. That's what those two arrows means. Proof that PR bisects QPS. So we want to prove that angle 1 equals angle 2. So to prove angle 1 equals angle 2. Right, so we're just going to put in angles here. 3, 4. Okay, so we want to prove that angle 1 equals angle 2. So what we're going to say is that angle 4 equals angle 1, sorry, angle 2, because it's an isosceles triangle. See the way you're given that, so that's an isosceles triangle. So you know the two of these are the same. Okie dokie. Now we're going to go for alternate angles. If you can't see it, you're looking for a Z or an N, and here's a Z, and that means angle 4 equals angle 1 because they're alternate to each other. So angle 1 equals angle 4, alternate angles. Therefore, angle 1 must equal angle 2. Therefore, PR bisects angle QPS. Okay guys, question 3. We'll just get bigger versions of it. Just so excuse me. There's angle 3. Question 3 I mean. So question 3. Let's have a look see. Alright. From the diagram, PR is perpendicular to RQ and UV is perpendicular to PQ. Prove that RPQ, R to P to Q, which we'll call angle 1, equals phi to U to Q. Phi to U to Q is angle 2. Alright, to prove angle 1 equals angle 2. So we know that angle 3 and angle 4, angle 3 equals angle 4, both right angles, which is given. We call this angle 5. Now look at the two triangles. So look at the red triangle. Let's start with the red triangle, right? The red triangle will be angle 2 plus angle 4 plus angle 5 equals 180. We say 3 angles in a triangle. Okay. And then you could go for the big triangle, which is the green one here. And you can say that angle 1 plus angle 3 plus angle 5 is also equal to 180 degrees for exactly the same reason, 3 angles in a triangle. Therefore, angle 1 plus angle 3 plus angle 5 equals angle 2 plus angle 4 plus angle 5. Now the angle 5's cancel, and we also know that angle 3 is equal to angle 4, so they cancel as well. So therefore angle 1 equals angle 2. And that is proven. Okay, so that was handy enough. Let's keep going. Okay, so let's continue to question 5, which is this fairly large diagram here. We'll reduce it down a little bit. So PQRS is a parallelogram. ST bisects PSR. So that means angle 1 will equal angle 2. Bisection. ST bisects PSR basically. Angle PSR. Happy days. Phi Q bisects PQR. So where's PQR? P to Q to R. So angle 3, angle 4 for the same reason. Phi Q bisects angle PQR. Prove that ST is parallel to Phi Q. So we want to prove that ST and Phi Q are parallel to each other. Okay, so that's an interesting one. We probably have to prove that both triangles are the same, so therefore they're the same angles. Okay, so we'll start off with what we know. P to S to T. So we're going to say that angle 1 equals RST, R to S to T equals angle 2 because it's given. Alright, so we already have that angle 1 equals angle 2. Now we're going to do PQV, which is P to Q to V, which is angle 3 equals angle 4. We have that done as well. Now we're going to go for PQV. Where's PQV? Angle 3 is equal to RVQ angle 5. So angle 3 equals angle 5 because they're alternate. Okay, so if we sort of list them all off, alternate angles. Okay, now is there any other ones that are alternate? We can call this angle 6 if you want. And then angle 2 will equal angle 6, also because it's alternate angles. Okay. Now, you might not even need that alternate part. Okay, so we have 5 and 6, alright? So once again, what we're looking to do, we're trying to get ST is parallel to Phi Q. Okay, so we're going to go for RQV, R to Q to V, which is angle 4. And angle 4, which is RQV, RQV is angle 4, equals RVQ. Equals angle RVQ, or angle 4 will equal angle 6. For what reason? Sorry guys, just going to pause it here for a second. Sorry guys, just rewind it back for a second. I got my 5 and 6 mixed up. It's angle 3 equals angle 5 for an alternate angle, and angle 2 equals angle 6, okay? Now we're going for RQV. RQV is angle 4, and we're saying that equals RVQ, which is angle 5. Alright? Now the reason why we've come to this conclusion is we have angle 3 equals angle 5, and we have angle 3 equals angle 4. So now we know that angle 4 equals angle 5. Okay? Yeah, so the whole point of this question, to prove that these lines are parallel to each other, we wanted to isolate that angle 5 is equal to angle 2 somehow. That is what we're really trying to figure out here, that angle 5 equals angle 2. And what we start off with is that angle 1 equals angle 2, because it bisects it. Angle 3 equals angle 4, because it bisects it as well. Then we had angle 3 equals angle 5, because of alternate angles. Alright? And then what we're going to try and link next is we found out that angle 4 here is the same as angle 5, right? So angle 4 is the same as angle 5. Alright, now so angle 4 is the same as angle 5, and what I want to prove is angle 2 is the same as angle 5. So for me, I would use opposite ends of a parallelogram. Right? So in a parallelogram, the two angles that look at each other have to be the same. So essentially this angle here, which is 1 and 2, has to equal 3 and 4. So that's the way I would have done it. I would have said angle 1 plus angle 2 has to equal angle 3 plus angle 4. And I would say is opposite ends, opposite angles in the parallelogram. Okay. Now, because they're bisected, okay, so because the parallelogram bisects them, okay, what we can next say is that this is 2 times angle 2, because angle 1 equals angle 2, and vice versa, this is 2 times angle 4, and 2 times angle 4 equals 2 times angle 5. Therefore, angle 2 equals angle 5, hence the two lines are parallel to each other, so hence QV and TS are parallel. Okay, good job. Now on to the next one, which is question 7. First thing I'm going to do is label all these angles. ABC, you're going to be number 1. BCD, B to C to D, you're going to be angle 2. CDA, C to D to A, you're going to be angle 3. And DAB, D to A to B, you're going to be angle 4. So what I essentially want to prove is that I want to prove angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360 degrees. Okay? Okay, so this is going to be a lot easier than you think. It's a simple answer. A quadrilateral is 2 triangles, and 2 multiplied by 280 degrees equals 360 degrees. That's it. That's it done. It's a bit of a cop out, really. Now, angle ABC plus CBQ. C to B to Q. Alright, I'm going to call this angle 6. I'm going to call this one angle 5. This one angle 7, and this one angle 8. ABC plus CBQ. So we're essentially looking for this part here. It's angle 1 plus angle 6 is 180 degrees because it's a straight angle. So angle 1 plus angle 6 equals 180 degrees because it's a straight angle. Okay, next one. To prove that PAB, so this is part 3, we're going to prove that PAB, which is angle 5, plus angle QBC, QBC is angle 6, plus angle 7, where's angle 7, which is RCD, which is angle 7, and then plus SDA, S to D, sorry, SDA, that's a 5, not an S, SDA is angle 8. And to prove that A equals 360 degrees. Well, the trick here is that we have a couple of straight angles. That's a straight angle, that's a straight angle, that's a straight angle, and that's a straight angle. So what we can say here is that angle 1 plus angle 6 plus angle 2 plus angle 7 plus angle 3 plus angle 8 plus angle 4 plus angle 5 equals 720 degrees for straight angles. But given that angle 1, angle 2 and angle 3 and angle 4 equals 360 degrees, you can then say it's 360 degrees plus angle 6 plus angle 7 plus angle 8, sorry I forgot angle 5, plus angle 5 plus angle 8 equals 720 degrees. Therefore angle 5 plus angle 6 plus angle 7 plus angle 8 equals 360 degrees, and that's basically what we're looking to prove. Okay, so we're done with that. So that's that. 1, 3, 5, 7. Did I do 5? I did 1 as well. So 1, 3, 5, 7. Now we're on to 9. Fantastic stuff. So question 9. PQR is an isosceles triangle with PQ equal to PR. This means this is an isosceles triangle essentially, so this would mean angle 1 equals angle 2. SQR is 90 degrees, so SQ to R, so this red angle would be 90 degrees. And SQ is a straight line, S to Q is one consistent line. Prove that PSR is isosceles, so we have to prove that we have to prove that this triangle up here, this red triangle, is also isosceles. Okay, so that's going to be fun. So what we're trying to prove is that angle 3 E equals angle 4. That will prove that's an isosceles triangle. So to prove angle 3 equals angle 4. Alright, so angle 1 equals angle 2. Isosceles triangle. Okay. Okay, I would say that angle 2 plus angle 3 equals angle 2 plus angle 3 equals 90 degrees because it's a right angle. Right angle. Okay. Now, what information can we assemble next? So angle 4 is, so we can say that angle 1 plus angle 4 has to equal 90 degrees. Now the reason why it equals 90 degrees is because sorry, we can do it like this. Angle 1 plus angle 4 plus angle 2 plus angle 3 equals 180 degrees. That's 3 angles in a triangle. Okay, this would therefore mean angle 1 plus angle 4 equals 90 degrees. And we have it now, lads. Look, angle 2 plus angle 3 equals 90 degrees. Angle 1 plus angle 4 equals 90 degrees. Therefore, we know that angle 1 equals angle 2, so we can say therefore angle 1 plus angle 3 equals 90 degrees. Therefore, 3 dots means therefore angle 3 equals angle 4. Therefore, triangle PSR is isosceles. Okay, let's try another one now. Okay, ABC is an isosceles triangle with AB equal to AC. BA is produced to D, so BA is extended onto point D, so that AD equals AB, so the length of D to A is the same thing as A to B. By joining D to C, so we're going to join D to C, prove that BCD, B to C to D, is 90 degrees, right? So I'm going to call this angle 1, I'm going to call this angle 2. And we call this angle 3, angle 4, angle 5, and angle 6, right? And I want to prove that angle 1 plus angle 6 equals 90 degrees. Okay, first thing I'm going to start off with is angle 1 equals angle 2 because it's a isosceles triangle. It's given to us. Okay. Then we can also show that angle 5 equals angle 6 because triangle CAD is isosceles. Okay. And we need to get a number into it, so I'm going to go for 3 angles in a triangle. I'm going to say that angle 2 plus angle 5 plus angle 6 equals 180 degrees. 3 angles in a triangle. Okay. Now, I also forgot, sorry, that was a mistake there. It's angle 5, angle 1 and 6 and angle 2. So I need to have angle 1 in here as well. Okay. Now, I'm going to replace angle 2 with angle 1. So it's going to be 2 times angle 1. I'm going to replace angle 5 with angle 6. So it's going to be 2 times angle 6 equals 180 degrees. Divide both sides by 2. I'm going to get angle 1 plus angle 6 equals 90 degrees. And that's pretty much what I was asked to prove. Okay, so let's have a look at this. OA, M is parallel to K. Okie dokie. And OA bisects PAB. Yeah, you can be angle 1, you can be angle 2, you can be angle 3, you can be angle 4, you can be angle 5. Prove that AOB is 90 degrees. So what's AOB? A to O to B. So prove angle 5 equals 90 degrees. Okay. How to even go about doing this? Alright, I have an idea. What I can say is there's corresponding angles here, or alternate angles, whatever you want to call it. I'm going to call this angle 6. Right, there's several ways to do this. Now, see the Z here? See the Z like that? And I can say angle 1 plus angle 2 equals angle 6, reason being alternate angles. Okay, now that I've done that, what I'm going to do next is I need to bring the angles into it somehow. Okay, now we know that within the triangle is 2, 3 and 5, so these are more important. So what I'd say there is replace angle 1. We know that angle 1 is equal to angle 2, because this is because OA bisects PAB, and we know that angle 3 equals angle 4 because OB bisects QBA. So technically speaking, that would be part of my solution. So I'm just going to chop and paste that down here. Sort of in the wrong order, isn't it? So I suppose I'll just do this. Move that over that side. Move that over here. Move that down there. Right, you get the gist. Now, here's what we're going to do next. Angle 6 plus angle 3 plus angle 4 equals 180 degrees. Okay. Now angle 3 is the same as angle 4. So that's going to be 2 times angle 3. And angle 6, as we discussed earlier, is the same as 2 times angle 2. Because remember we said that earlier. Did I copy and paste that over? Did I? Because angle 1 equals angle 2. So we could also say 2 times angle 2 equals angle 6. Remember, we're just replacing angle 1 with angle 2 from up here. So then we can say 2 times angle 2 plus 2 times angle 3 equals 180 degrees. And the reason for that is a straight angle. Okay. And then what we're going to say next is that angle 2 plus angle 3 equals 90 degrees. But when you look at the inner triangle, angle 2, angle 3 and angle 5 has to equal 180. So therefore angle 5 equals 90 degrees, which is what I was asked to do. Okay, so that's question 11 done. I think I'm moving on to 13 now. I'll just pause it here for a minute actually.